All right, Algebra 2, number 57 on the review. Plot the graph. All right, we're going to take a shortcut here just because since it's not asking for anything but us to figure out which graph this is. Here's what I'm going to do. I'm going to make an XY chart, and I'm going to pick easy X values we can evaluate. So if X equals 2, we just plug it in the equation. So Y is negative 2 over 2, Y would be negative 1. So if X was negative 2, Y would be 1. So all we got to do is see which one of these is this all true to. So when X is 2, Y is negative 1. And when X is negative 2, Y is positive 1. So we need one that has in the second, fourth quadrant. Well, if you look, the only one that does that is B. Okay? Next example. Y equals 4 times 2 to the x power. Well, we know that's exponential growth. So we can cancel out that one because that's dk. That one's no good. So it can be A or B. So when x equals 0, it'd be y equals 4 times 2 to the 0. What's 2 to the 0? 1. So it'd be y equals 4. So when x is 0, y is 4. Okay, x is 0, y is not 4. So C is not right. X is 0, y is 4. Going up. So my answer is D. 59. An initial population of 505 quail increased at an annual rate of 23%. Write an exponential function to model the quail growth population. Well, we always start with our initial amount, and then it's going to be 1 plus the rate or 1 minus the rate. Since it's an increase, it's going to be 1 plus the rate to whatever x years they have. So it would be 505 times 1.23 to the x power. Answer is D. 60. Write an exponential function y equals ab to the x power for the graph that includes 115 and 0, 6. So those represent x and y values. So let's do it when x equals 0. So we're going to plug that in. So we get 6 equals a times b to the 0 power. Well, what's anything to the 0 power? 1. So 6 equals a. Alright, that's good to know. Now plug in the other one with our a variable. So now it's y equals 6 times b to the x. Well, we know x is 1, y is 15. So I got 15 equals 6 times b to the first power. So 15 equals 6b. Divide each side by 6. So we get 15 over 6 equals b. So that's going to be 2.5 is our b value. Well, now I can go and say y equals 6 times 2.5 to the x power. Answer is A. 61. Y equals 7 times 1/4 to the x power. Okay, we'll just do an XY graph real quick. Here's what we know. Let's pick an easy one. When x equals 0, y is going to be 7. So that one's in the ballpark. That one's not. That one's not. This one is. Okay, that is a fraction. That's less than 1, so it's exponential decay. So the answer must be D. 62. Y equals 5 times 2.1 to the x power. So we know it's exponential growth. It's going to cross the y-axis at 5. Exponential growth crossing the axis at 5. The answer is A. 63. The half-life of a certain radioactive material is 85 days. The initial amount of the material of the mass of 801 kilograms. Write an exponential function that models the decay of this material. Find how much radioactive material remains after 10 days. So the half-life of anything is y equals a times 1/2 of x over 85. So y is going to equal 801 times 1/2, 10 days, 10 over 85. Answer C. Plug that in your calculator and you find out. Use a graphing calculator. Graph or just evaluate e to the 1.7. So we can do that on our calculator. That's easy stuff. So we turn them on and we pick our e to the 1.7. 5.473. Answer's A. Easy calculator work. 65. Suppose you invest $1,600 at an annual interest rate of 4.6 compounded continuously. Well, compounded continuously gives me A equals P to the ERT power. So the amount I accrued is my principal, which is 1,600, times E to the rate of 0.046 times 4. So again, easy calculator work. 1,600 E 0.046 times 4. 1923.22. Answer is D. 66. Write the equation in logarithmic form. So 6 to the 4th power equals 1,296. We could say this. Log base 6 of 1296 equals 4. Remember, the shortcut is this to this power equals that. 67. Evaluate the logarithm. Okay. Well, we could do this a few different ways. Since it's a base 3, we could sit there and factor 243 down with 3. So 3 goes into 24, 81 times. 81 is 3 times 27. 27 is 3 times 9. 9 is 3 times 3. So I got 1, 2, 3, 4, 5. So the log base 3 of 3 to the 5th would be 5. An easier way on your calculator to do it would be log of the big number, 243, divided by log of the base, log of 3. You get 5. Answer's 5A. Okay, 68. State the property or properties of logarithms used to rewrite this expression. Log base 5 of 6 minus log base 5 of 2 is the log base 5 of 3. Since it's a minus sign, we know it's a quotient property, A. Okay, 2 log 6 plus log of 1/3 equals log of 12. So we could rewrite 2 log 6, a log 6 squared, okay, plus log of 1/3. So log of 6 squared can be rewritten as log of 36 plus log of 1/3. So that's the same thing as the log of 36 times 1/3, which would get us log of 12. So we use the power property and the product property. So the answer is A. 70. Expand the logarithm. Log base 7 of n over 2. That'd be the same thing as log base 7 of n minus log base 7 of 2. The answer is A. So 71 says this: solve 15 to the 2x power equals 36. So 15 to the 2x power equals 36. So since I have a variable in the exponent, we're going to log both sides. So I'm going to get log of 15 equals log of 36. Sorry, log of 15 to the 2x power. Power property says I can drop the 2x. So it's going to be 2x log of 15 equals log of 36. So 2x is going to be the log of 36 divided by the log of 15. So let's do that. Let's go log of 36, enter, divided by log of 15, enter, and then divide that by 2. So x is going to equal 0.6616. Let's get check our calculator. Yep. So the answer is A. 72. Solve 3 log of 2x equals 4. So let's look at it. So I've got 3 log of 2x equals 4. So what we're going to do is divide everything by 3. So I got log of 2x equals 4/3. Okay, remember, what's the base if it's not given? Well, the base is 10. So what we're saying is 10 to this power equals that. So we're saying 10 to the 4/3 power equals 2x. Or we're saying x equals 10 to the 4/3 power over 2. Okay, so let's do that on our calculator. Okay, so 10 raised to the 4/3 power equals 21 and some change. Now divide that by 2, you get 10.7722. The answer is A. Okay, moving on, 73. Write this expression as a single logarithm, or natural log. Okay, 3 natural log x minus 2 natural log c. So the first step is we use the power property and rewrite this as the natural log of x cubed minus the natural log of c cubed. And now we can use the quotient property, so it's the natural log of x cubed over the natural log of c squared. Or not, yeah, natural log of x cubed over c squared. Answer is A. 74. Solve the natural log of 2x minus 1 equals 8. Well, the base of the natural logs is e. So if we raise everything to the e power, I'm going to get 2x minus 1 equals e to the 8th. So 2x equals e to the 8th plus 1. So x is going to equal e to the 8th plus 1 all over 2. So get our handy dandy calculator out. And we'll move it over here and do some work. So we've got e to the 8th, enter, plus 1, enter, divided by 2, enter. I got 1490.979. Answer's D. 75. Use natural logs to solve the equation round to the nearest thousandth. So I got e to the 2x power equals 1.4. So I'm going to natural log both sides. So that's going to allow me to do 2x, the natural log of e is 1, equals the natural log of 1.4. So x is going to be the natural log of 1.4 over 2. So get our handy dandy calculator out. Let's do the natural log of 1.4. Hit enter. Divide that by 2. Oop. Let's try that again. Answer divided by 2. 0.168. So I got the answer C. We've already done 76. So there we go. That concludes this part of the review.